blow that water out. All right. The pressure that's working against me by the water in the water hose would be like afterload, because I have to work against that pressure to get the air out of the hose. All right, so let's think about it like this. Right? We know that, and we'll talk about blood pressure in just a minute, but we know that you have two numbers for blood pressure, right? We have the top number and the bottom number. The top number is the blood pressure. Systolic, which is the pressure in the system when the heart contracts. All right, and so the diastolic is the pressure in the system when the heart's at rest. So, which one of those numbers do you think affects the afterload? Systolic. But which one is the residual pressure in the system? Diastolic. So when that heart first starts to pump, it has to work against the pressure that's already in there. All right. So say if the pressure already in there is 70, it's got to work against that 70 to get the blood out of the system. Right. Your afterload will affect stroke volume. All right. The higher the afterload, the less blood you're going to get out. All right. Your afterload is affected by arterial pressure, and factors that increase afterload is the obstruction of the aortic valve. We know that in order to get out of the heart, the blood must pass through the aortic valve. If that valve is obstructed, it's going to raise the pressure. Circulatory fluid overload. If there's too much fluid in the system, it's going to raise the pressure. And then a high systemic blood pressure. All right, if you have high blood pressure throughout your whole system, it's going to raise your afterload. Alright, a brief reminder regarding blood pressure. It is the pressure that blood exerts on the arterial walls as it's traveling through. Alright? This is very important. I would write this down. Blood pressure is cardiac output times peripheral vascular resistance. Fall in love with that formula. It will stay with you throughout the rest of your education. This is really all going to click in the door while you're like, woohoo, it all makes sense now. Right. So blood pressure is cardiac output times peripheral vascular resistance. Right? So how much you're putting out by how much pressure is it working against. That's your blood pressure. Right? Cardiac output is stroke volume times heart rate. Right? So remember, stroke volume is how much blood we're putting out each time the heart beats, multiplied by the heart rate. So how much every time it beats, multiplied by how many times that's happening in 1 minute. Alright. So for easy math, let's say I put out 1 liter every time the heart beat, and you're beating 60 times a minute. In 1 minute, you would put out 60 liters. Does that make sense? That's not really what you put out, but it's easy math. Peripheral vascular resistance is related to the diameter of the arteries. All right, the smaller the arteries, the more resistance. The bigger the arteries, the less resistance. What? I did this. I looked at these slides real quick for them office and I realized they were kind of crappy, so I had to add a bunch to them real quick. Still flying? Good. Talking about types of blood vessels. This should all be a review. Arteries, arterioles, capillaries, venules, and veins. And that's the way it starts off with arteries, breaks into arterioles, capillaries, capillaries into venules, and venules into veins, which then go and return back to your heart. This diagram, which is on page number 243 in your book, is a spectacular depiction of how this whole system works. What page? 243. Okay, well on his is page 247, on mine is page 243.
Mine's 243.
Okay, it's in the chapter somewhere. I'll let you check that out in your own time. It's really, study that picture. It's just a really good review of what we talked about before. But that night I drew that whole big long thing out on the board. That's it. It is good. All right, let's talk about your microcirculation system. All right, until now we've only talked about, you know, the system. Well, when we say, well, when it gets to the capillary, we haven't actually talked about what goes on once you get there and how all this works. But your microcirculation system responds to the individual needs of the tissues that it serves. All right. We know that arterioles branch off into capillaries, right? Well, before that happens, we have this group of tissues called precapillary sphincters. All right, and that is how we control the amount of blood that gets into the capillaries. All right, and that is controlled by many things, including the sympathetic nervous system and the needs of that tissue that capillary serves. For example, if the tissue this capillary serves needs more oxygen, those precapillary sphincters are going to open up and allow more blood to flow into that area. Whereas if that tissue that capillary serves had enough oxygen, is doing okay, it's going to close it off and divert the extra blood to another part of the body where it's needed more. Right? So the arterioles are actually what control the blood flow to your tissues. All right, it's the size of the arterioles, you know, how big they're expanding and how small they're contracting, that determines where the blood flows in your body. What you also need to remember is generally what happens is when they constrict in one area, they're going to dilate in another area. That maintains the overall volume of the system. All right. Think about one of those big long balloons they make a little dog out of the surface. All right. If I take that balloon and I squeeze it on this end, right, it's going to blow up real big on this end, but the volume of the balloon hasn't changed. Right? It still has the same amount of air in there, but I squeezed it real tight here, so it blew up real big over here. Okay, does that make sense? If I squeezed it real tight in the middle, it blew up real big on the ends. But the, you know, small here, big here, but the overall volume hasn't changed. That'll mean something to you when we talk about neurogenic shock. Let's take a little break. See what this PowerPoint shows. I told you I put some thought into this.